Today, we will compare two ways to rotate figures: the rotation rules and the general rotation formula, by using a simple line segment as an example. Let us start with the rotation rules. These are specific shortcuts we use when rotating points about the origin by angles like 90 degrees, 180 degrees, or 270 degrees. Let us use this example: a line segment AB, with points A at 2, 1 and B at 4, 3. We want to rotate this segment 90 degrees counterclockwise about the origin. Using the rotation rule, open parenthesis x, y close parenthesis becomes open parenthesis negative y, x close parenthesis. Apply this to each point. Point A at 2, 1 becomes a prime at negative 1, 2. Point B at 4, 3 becomes B prime at negative 3, 4. So, the new image A prime B prime has coordinates negative 1, 2 and negative 3, 4. That was quick and easy because the rotation is about the origin and the angle is standard. Let us now continue exploring the rotation rules, this time for 180 degrees and 270 degrees counterclockwise rotations, using the same line segment AB, with A at 2, 1 and B at 4, 3. First, 180 degrees counterclockwise rotation. The rule is, open parenthesis x, y close parenthesis becomes open parenthesis negative x, negative y close parenthesis. Apply this to both points. Point A at 2, 1 becomes a prime at negative 2, negative 1. Point B at 4, 3 becomes B prime at negative 4, negative 3. So, the rotated segment A prime B prime now has coordinates negative 2, negative 1 and negative 4, negative 3. This kind of rotation turns the figure halfway around the origin, flipping it to the opposite quadrant. Next, 270 degrees counterclockwise rotation. This is the same as a 90 degrees clockwise rotation, but we will stick with the counterclockwise interpretation. The rule is, open parenthesis x, y close parenthesis becomes open parenthesis y, negative x close parenthesis. Apply it. Point A at 2, 1 becomes a prime at 1, negative 2. Point B at 4, 3 becomes B prime at 3, negative 4. So, the rotated segment A prime B prime now has points 1, negative 2 and 3, negative 4. This moves the figure 3/4 around the origin in a counterclockwise direction. These rules are fast and efficient, but remember, they work only for rotations around the origin. Now, what if you are rotating a figure around a point other than the origin, but you still want to use the familiar rotation rules? There is a helpful three-step method you can follow, especially when the angle is 90 degrees, 180 degrees, or 270 degrees. Here are the three steps. Step 1. Subtract h, k. Temporarily move the center of rotation to the origin by subtracting the coordinates of the center point, h and k, from each point you are rotating. Step 2. Apply the rotation rule. Now that the center is at the origin, use the standard rotation rule for the angle. For 90 degrees counterclockwise, use negative y, x. For 180 degrees, use negative x, negative y. For 270 degrees counterclockwise, use y, negative x. Step 3. Add h, k. Finally, move everything back to its original position by adding h and k to your new coordinates. A line segment AB has endpoints A at 2, 1 and B at 4, 3. Rotate the segment 90 degrees counterclockwise around point A. Use the three-step rotation method. First, translate point B so that point A becomes the origin. To do this, subtract the coordinates of point A from point B. 4 minus 2 is 2, and 3 minus 1 is 2. So, the translated coordinates of point B are 2, 2. Second, apply the 90 degrees counterclockwise rotation rule, which is, x, y becomes negative y, x. Applying the rule to 2, 2 gives us negative 2, 2. Third, translate the point back to its original position relative to point A by adding point A's coordinates. Negative 2 plus 2 is 0, and 2 plus 1 is 3. So, the new coordinates of the rotated point B are 0, 3. Final answer. The new image of point B is at 0, 3. The new position of segment AB is from point A at 2, 1 to point B at 0, 3.